In this lesson, we're going to learn how to perform function operations. Just as you can add, subtract, multiply, or divide two numbers, you can do the same with two functions. So let's illustrate this with the following two functions. F of x and g of x are shown on your screen, and let's start by stating the domain of each. Well, x squared plus 2 is going to be a parabola, so my domain here is going to be all real numbers. And then I have a linear function, so that's going to have a domain of all real numbers as well. You could also list this as negative infinity to positive infinity. Now, for the majority of the function operations you do, add, subtract, and multiply, your domain is going to be the intersection of these two domains. So I'm going to have all real numbers for those. Now, when you do the quotient, it's possible that new restrictions can be introduced because now you could have like a divide by zero error, so you're going to have to think about any new restrictions. So the notation that you see here on the screen, f plus g of x, is equivalent to taking your two functions, f of x, and adding it to g of x. All right, so you'll see it written one of those two ways. So all you're doing is x squared plus 2 plus 4x plus 1, and really you're just combining any like terms you see to get x squared plus 4x plus 3. So my domain is still going to be all real numbers. So to subtract f minus g of x, again, this is equivalent to f of x minus g of x. Now with subtraction, you just need to be careful to recognize that you are subtracting the entire second function, which often will cause you to need to distribute your negative value. So it would be minus 4x minus 1. I'll just recopy this first. And let's see if we have any like terms. Looks like I now have x squared minus 4x plus 1. And the domain is the intersection of the two. It's all real numbers, or just look at it, it's going to be a parabola. All right. The next notation, f times g of x, is equivalent to f of x times g of x. And just don't get this mixed up. You're going to see notation where there's like an open circle like this. This is the composition of function, kind of looks like fog there. This is not equivalent to f times g of x. So we're just going to multiply our two functions together, which actually gives me two binomials being multiplied. So you are going to distribute the x squared gives me 4x cubed plus x squared, and then I distribute the positive 2 gives me plus 8x plus 2. And then you check and see if you have any like terms that can be combined, and I don't, so f times g of x is equivalent to this cubic function, and the domain of this is still going to be all real numbers. Finally, let's look at division. So this is again equivalent to f of x divided by g of x. With division, it's possible that there are new restrictions in your domain. So this is going to be x squared plus 2 over 4x plus 1. And I check, can I reduce anything? No, but there is going to be a restriction. If the denominator is equal to 0, it's going to break my domain here. So I need to say that the denominator cannot equal 0, and therefore x cannot be negative 1/4. So my domain now will be negative infinity to negative 1/4 union negative 1/4 to positive infinity. So everything except for that. So here is my solution. Let's quickly go through another example. And in this function, for f of x, it's cubic, so my domain is all real numbers, and then I have a linear function, so it's also all real numbers. So first I'm told to add these two functions, which is pretty simple. no like terms, so that's as nice as it can be. I see down here in part G it's going to tell me to state the domain, so it's the intersection of my two domains, so it's still all real numbers. Then I am to subtract f of x minus g of x, so there's that, nothing to clean up there, all real numbers. Next I'm told to multiply, so this is 6x cubed times 2x. That's going to equal 12x to the fourth, a quartic function, and the domain, again, is all real numbers. Now, with division, it is possible that I have some new restrictions here. So this is 6x cubed divided by 2x, and I can clean this up a bit. And it does reduce to just 3x squared, but when I'm talking about my domain, I'm talking about this original before I reduced. So I would have divide by 0 if x is equal to 0. It would break the domain. So my domain is actually going to be everything excluding 0. So that is negative infinity to 0, 0 to infinity. And now let's look at one with a little bit more of an interesting domain. So first of all, in f of x on this one, my domain would be all real numbers. But g of x, I cannot take the square root of a negative value in the real number system. So this would be x minus 8 is greater than or equal to 0. So x is greater than or equal to 8. So my domain here is 8 to positive infinity. Okay, so for the first three operations here, my domain is going to be the intersection of all real numbers and 8 to infinity. So that means that this domain right here is where they will overlap one another. All right, so f plus g of x is equal to 4x plus the square root of x minus 8. And those are not like terms, so just right away I'm going to state my domain is 8 to infinity. And then I'm told to subtract, which doesn't change things a whole lot here. Can't really clean that up a whole lot algebraically. So again, 8 to infinity for my domain. Multiplication will be 4x times the square root of x minus 8, and my domain is 8 to infinity. For division, I will have 4x over the root of x minus 8, and I'm definitely going to have some new restrictions here. So I can't have anything that would cause my denominator to be 0 here. So if x were 8, my denominator would be 0. So now 8 is excluded from the domain, so I'm going to switch that to a parentheses.